Activity 4, exponential function y is equal to a times c to the bx. Role of parameter b, where b is greater than 1. A bacterial culture contains 100 bacteria initially. The number of bacteria doubles every 15 minutes. Consider the function f, which associates to the elapsed time t in hours the number of bacteria present in the culture. A. Complete the given table of values. All right, so we're starting off with 100 bacteria after 15 minutes. Now, 15 minutes is 0.25 is a quarter of an hour, right? So 15 out of 60 divided by 60 is 0.25, a quarter of an hour, a half an hour, 3/4 of an hour. So this is every 15 minutes. All right, so the bacteria is going to double, so we're going to expect to get 200, and then we double the 200, 400, double the 400, 800, double the 800, 1,600. Determine the parameter a and the base c of the rule of the function y is equal to a times c to the power of t. I'm going to replace everything I know. So the y is the final amount. I'm going to keep that as y, but the a is the initial amount. It's 100. The c, it's doubling, so that's going to be 2. So we're going to have y is equal to ac to the power of t, which is going to be 100 times 2 to the power of t. C. The number of bacteria doubles every 15 minutes. We write the rule obtained in B in the form y is equal to a times 2 to the bx. Our unit is in hours, right? Our units are in hours here. Because we're talking about it's doubling every 15 minutes, our unit of time down here is in hours. So how many doublings happens per unit time? There's 4 doublings per unit time. So it's going to double 4 times per hour. So the B is going to be 4. So if we're looking at y is equal to a times c to the bt, we're going to get y is equal to 500 times the c is 2. The b is going to be 4 times t. Interpret the role of parameter b. The b makes each doubling, in this case, time equal to 1. The b is how many doublings happen in 1 unit of time. And the unit of time we're talking about is an hour. So how many doublings happen in an hour? 4. Here, t must be adjusted. We know that the doubling is happening every 0.25 hours, not every 1 hour. So we multiply our times by 4. Here you'd have to do the same thing. You would have to just multiply whatever your time is by 4. Like, so if it was an hour, we'd have to realize that's 4 15-minute. So the t is going to be 4 in that case, or 4 times t. So whatever our time was, if we knew we were going to be running the experiment for 5 hours, we would have to say, well, that's 15 minutes is going to finish that 20 times, so our time becomes 20. So down here, by breaking it into bt, we can say, all right, our unit of time is in hours, and it happens 4 times per hour, so there are going to be 4 doublings. So b is like, how many doublings do you have per unit time? B is equal to 1 over p. Now p is like the time unit, 1, and p is the doubling period. So it doubles every 15 minutes, every 0.25, so 1 over 0.25, or 1 over 1/4, in this case, would be 4, so b would be 4. In this case, we are doubling. In other cases, we could be tripling or halving or 3/4ing, so just remember, it's not always, the c is not always 2. That's it for activity 4. The exponential function y is equal to a times c to the bx. So we're looking at the role of parameter b. The time unit being well defined, the independent variable x represents the time elapsed since the beginning, x equals 0. The dependent variable y, the number of bacteria accumulated, capital, etc., takes on values which are periodically multiplied by a constant factor. A represents the initial value of the dependent variable. So A is the initial value. B represents the number of periods per unit of time. So if we're talking about hours, it's how many times does it double or triple or whatever per hour. C represents the periodic multiplicative factor. Okay, is it doubling? So C is 2. If it's tripling, C is 3. If it's halving, C is a half. Okay, which multiplies the variable y at each period. An example, an environment initially contains 10 bacteria. The time unit is the hour. When the number of bacteria triples every 15 minutes, okay, that means we're going to have 4 time periods in the hour. Okay, so the period is 15 minutes out of an hour, which is 0.25. Each hour contains 4 periods. B is equal to 4. The rule is y is equal to 10 times 3 to the power of 4x. When the number of bacteria doubles every 30 minutes, each hour contains 2 periods. The rule is y is equal to 10 times 2 to the power of 2x. When the number of bacteria quadruples, c is equal to 4, every 2 hours, Each hour contains 1/2 periods, so b is equal to 1/2. The rule, y is equal to 10 times 4 to the 1/2t. And that's it for the exponential function. Have a good day.